So what we're going to do is we are going to take a peek at these things called a compound inequality. And basically, they're a little bit different from the first ones we did. We did some stuff with the arrows and when to flip the arrow and things like that. But what we're going to do now is we're going to take two separate graphs and we're going to put them together on one. And so, for instance, instead of getting into some of the mumbo-jumbo here at the top, I'm actually going to just move down. We're going to jump in here. Okay, so graph the solution set of each compound inequality. Okay? B is greater than 1. Now remember, if you have a variable, whether it's b, x, whatever it's going to be, and that arrow is eating your variable, that's always going to be greater than, oh, nobody tell me I'm even off the screen here, and my arrow is going to go to the right for that one. Okay? The arrow is eating my variable, that's greater than. Every time. If the arrow is pointing at my variable, that is going to be less than, and when I'm drawing my arrows, my arrow will always go to the left. So when I'm doing these, sometimes, and we'll start to learn a little bit of a pattern here with these, but as I start to look, I'm like, okay, so b is greater than -1. Am I going to be going to the left or to the right? B is greater than, if it's eating the b, which way is my arrow going to be? To the right. So a couple of things to keep note of here. Okay, I know my arrow is going to go to the right. There's one other little detail that we have to pay attention to. Well, for right now, we're just making some note of some things so we can keep this simple. So here, then I have one more decision I have to make. The circle that I put on -1, if it's going to be open or closed. You're right. And it's going to be open because it's just greater than. So let me put one more bit of note up here. Right. So whenever I have greater than, if I have an arrow that's just by itself, that's going to be an open circle. If it has the or equal to line underneath, which Eric mentioned, that's going to be a closed circle. So there's two things we're looking for on every one of these graphs that we do. Is it an open or closed circle at the point, or which direction is my arrow even going? So we figured out that number 1, we're heading to the right, and we also figured out my circle is going to be open. So I look and I go, okay, open circle on -1, and it's going to be going to the right. Now I'm not going to make it real long right now. I'll make it kind of short. Just kind of put it in there. So then when I go to do the other one, let's see what happens. Yeah, b is less than or equal to 3. Less than is left, and it's going to be closed because it's or equal to. So I put a closed dot on 3, and it's going to the left. And what you notice is going to happen is the arrows come in from the endpoints, they're going to crash together. So when I go to graph this, I'm actually going to just color in between the two dots. That's where all my answers are. So if I plug in any number between these 2 points, it's going to be true for both of those. So like, let's say I plugged in 1. 1 is greater than -1. 1 is less than 3. They're both true. Any point outside of those isn't going to work. So you're like, okay, this might be all right. Whoa, what is going on here? We're going to simplify this in a minute, but here's how these work. We're going to look at them separately. So here, I look at this and I say, okay, the arrow's pointing at Q, so that's going to be less than. Yeah, that's the part that's tricky. We can't just follow the arrow. The arrow's pointing at Q, so this is less than. Less than is going to be to the left. And then what type of dot am I going to have there? Closed, because the line's colored in. So I go to where it's 2. I'm going to close my dot. That arrow is going to be going to the left. So then I switch it up. I say, okay, I'll cover up this part. So it's still like doing 2 separate ones. I'm just kind of seeing how it works. Q is greater than or equal to -5. Greater than, when the arrow eats the Q, means my arrow is going to be going to the right on this part. And it's still going to be closed. So I go to -5. Close my dot. And I go arrow to the right, and I notice the same thing's going to happen that happened on the first one. If my arrows kept going, they're just going to crash in the middle. So nothing too different to be dealing with. Yeah. Yeah. So what you start to notice is, I can get the same type of graph working here, even if it's 2 separate ones versus one big one. And that's why I want to look at them separately. So you're like, okay, I might be getting the hang of this. So like 3, same thing. Open or closed? Open. Open on -3. X is greater than, so am I going right or left? Right. Some of you are like, I think I see a pattern developing here. I'm going to try and shortcut this. And I'm going to show you an exception to the rule here. Okay. My other part, open or closed? Closed, because I've got the or equal to. X is less than or equal to 4. Which way are we heading? Less than heads left. Less than heads left. So you're like, are every single one of these just going to end up crashing in the middle? Because if they are, shoot, I'm going to start whipping through them. Not exactly. Let's take a look at number 5, just so we don't get into a bad habit here. This one. Now again, watch where your variable is. Let me bring this down a little bit. Watch where your variable is in regards to this. So here the arrow is eating D. So if the arrow is eating it, that's greater than. My arrow is going to go to the right, and it's going to be open. So I come down here and I go, okay, so -3, open, heading to the right. Okay. Then I look at the next one. D is less than 2. Which way is that going? Left. Like, dang, Hardy, it's still going that same way. You're like, this is sweet. It's just going to keep coloring in the middle. Okay? This is what's called, an and statement, because we end up coloring in the middle, sort of like the 2 examples at the top too. So now, let's flip over to the back. Now it changes a little bit, because now instead of seeing the word and in the middle, I see the word or. That changes things. Well, how so? The rules are still the same with trying to figure out what direction to go and with my dots open or closed. But what we're going to see now is that B is greater than 2. Open or closed in what direction? Open. Open and to the right because it's greater than. The arrow's eating my variable, it's always greater than. And then I look at the other one. Open or closed at -3. Closed because it's or equal to. And this one's going to the left because it's less than. You're like, okay, now wait a minute. Now they're going opposite direction. What's the deal with that? When you see ors, they typically have arrows that go out. That's kind of the easiest way to remember. Ors go out, ands come in. You almost do it like a little dance step. Luckily, you can't see this on video. But like it's like the ors and the ands, and I look like I'm doing some funky 50s dance step. Okay, I'll keep my day job. So, but that's how these are going to work. If you see the or in the middle, typically they're going to go out from each other, but not every time. Number 8. Arrow's pointing at Q, which is less than. What direction does our arrow go when it's left? Left. Ooh, L and L. So we're going to go left. It's going to be close. So here's 3. Close. Going to the left. I'm going to do the other one. Q is less than or equal to 1. Less than left. Wait a minute, why are they going the same direction? So here's 1. Close it, and it's going to the left. Well, what the heck? They both can't go the same direction. Yes, they can. So here's how this is going to work. If it's an or, and they're both going the same direction, you need to make the longer line. In other words, whichever line is going to be longer over a time period is going to be the one we want to use. So it's longer if I start at 3 than I do at 1. So my answer is going to be to start at 3 and head to the left. And that's what we've got working. So sometimes they'll go out and go opposite directions, but if they go the same direction, we're just going to make the longer line of them. Okay, work it that way. So let's see here. Let's jump down to 10, and then I'm going to let you try some of these out here. But again, keep this handy because it kind of gives you some good direction. All right, P is greater than or equal to 4. Notice I didn't say 4 is less than or equal to P. I always want to talk as though I'm talking from the variable's point of view. So if P is greater than or equal to 4, open or close. Close because P are equal to. And left or right if it's greater than. Right. Close to the right. And then for my other one, open or close. Open because it's just less than. You're like 8. Party, where's 8? 8's not even on here. Sorry about that. Open. And less than goes which direction? Less than goes left. You're like, well, wait a minute. Now this is looking like the ands that we did. Do I just color in the middle? No. If you get one where your ors come together, so like where they're going to cross like the ands did, whoops, I lost the letter, I'm sorry, color the whole line because everything's an answer. Because this one's going to keep coming straight through, and so is this one. And that kind of gives us every possibility. The ors have a little more complicated than the ands. Something a little more to think about. So here's going to be kind of our thing for today. Like I said, this we're going to keep as examples. This you need to hang on to at all times. Okay, this one doesn't get turned into me. But what I'm about to give you here is going to be, I'll kind of pause, is now we've moved to the actual homework here. And when it talks about things like writing an inequality for the following graph. Okay, so I'm going to look at this in pieces. So let's start right here. So this, we'll just call this X. Does an open circle mean my arrow is going to be underlined or not? Not, okay? And it's going to the right, which is greater than or less than. greater. So x is greater than whatever my point is there. So x is greater than 0. Or, if I look at this piece, looks like my arrow's going left. So left is less than. Am I going to put the line underneath it? Yeah, my dot's filled in. So I need the line underneath it. And it looks like it's in negative 5. So my inequality is x is less than or equal to negative 5. It goes left. It's filled in. Or x is greater than 0 because it's open there. Okay, that's how I'd write my inequality. You're like, ooh, what's going on after that, though? What the heck? When I get down below, it's like, for instance, for number 3, I got to have x alone in the middle to be able to do that. Now, we saw one where it was like this, but we didn't have to perform anything. What's my one step to get x by itself if I'm multiplying it by 8? Divide it by 8. And you divide everything by 8. So negative 16 divided by 8 is negative 2. That's just x. That's what I wanted. 40 divided by 8 is 5. And now it looks more like one of the examples from the homework. You're like, okay, so if I cover up this part, what type of circle am I going to have at negative 2? Closed. Closed at negative 2. Then I look again and I'm like, okay, the arrow's eating x. So that's greater, so that's to the right. That little arrow here. And I cover that up. Open or closed at 5. Open. And x is less than. Which way is my arrow going to go? Less than goes left. They both start with L. And since there's not an or on this one, we just connect them. We just play connect the dots. So ands we get to play connect the dots. Ors we just color right on through. So I keep kind of working my way through. I'm like, okay. So it's just kind of throwing the algebra equations in with this stuff. I see what you're up to. So I see this next one. And I'm like, okay, I see or. I want to get b by itself. How do I get... Okay, on this side I would. Okay, we can do this one first. So I can times each side by 10 over here. Those will cancel out. So b is greater than 10 over on that side. Okay. So let's see. If b is greater than 10, so here's 10. We're counting by 2's. What type of circle am I going to have on 10? Open. It's greater than. And greater than goes to the right. On the other part, with my other inequality, what's my one step to get b alone? Add 6. So I'm like, okay, let's see here. Open or closed at negative 7. Closed because we have this line underneath. And if b is less than, what else starts with L with the direction? Oh yeah, left. So my arrows are heading both directions. With that one. Like I said, this is more of us blending equations and inequalities together. Get a little bit of a feel for it, as much as anything else. Alright, to the back. Knock these guys out. The experts. I already forgot which types I'm doing. Oh yeah, I'm doing the odds. Okay. Doing the odds. Ooh. Complicated in the middle. I need to get that negative 10x alone first. How do I tell the 5 to go away? Okay, we're going to minus it here. So we're doing add and subtract so far. We're going to divide coming. Minus the 5 first. It's going to take us 2 steps, but we're going to get there. One step to go. Since we're multiplying x by negative 10, what's the opposite? Divide it. Now there's one more trick with this. Nice, okay? If you divide by a negative, okay, to get your x alone, you have to flip the arrows. So here I divided everything by negative 10, so both sets of arrows flip and head the other direction. So this is my inequality. And just like it has been every other time, and we can sort of start to cheat a little bit this way. All I've really got to do now, since I see the compound one big like this, is I got to say, okay, is my dot at 10 going to be open or closed? It's going to be closed because it's or equal to. My dot at negative 5 is going to be open, and when I see these big inequalities like this, they're all in one big piece, I'm just going to color in the middle, because that's just how they work. So you're kind of wishing it all don't come up that way, right? So my last one then, that I'm going to talk through with you here on, is going to be number 9. Now it's an or again, so remember, the ors are the tricky ones. They can go out, they can go one direction, they can go all the way through, we never know. So, we'll start over here. Alright, let's work on getting 10n alone. Okay. Add 9, I'm minusing 9, I'm going to do the opposite. Then divide by 10. It's like an equation, but there's an arrow in the middle. So when I get here, might as well graph it while I'm here. It's open because there's no line. And greater than goes right. And you can always think about it too as if I plugged in a number, which way would it go? So like, you know, if I plugged in 10, is 10 greater than 8? Yep, I make my arrow the same direction. Same deal here, I want to get my n term alone first. What would I have to do? Got to add the 8 to get it out of there. Okay, we divide by negative 7, and just like we did up in number 7, since I'm dividing by a negative, I've got to flip the arrow. I look at it and I go, okay, so negative 4, let's see, it's open, because it's not or equal to. There's less than, which goes left. That seems pretty normal. I send that out that way. Darn. So today, twofold things for a lot of you to get done. Number 1, you only got 5 questions that you have to deal with on here. So knock those 5 out and get this one in. We need points. We need points desperately. If you still have stuff from the percentage unit we just got done with, and you still have it, finish up as much as you can and get them in. I'm only taking them for a couple more days, and then I'm going to quit taking them. And I don't want some of you having to come up to me, you know, beginning of December, going, well, you know, here's 15 sheets. And I go, yeah, I'm not taking them. You've got to keep with me. So now, also, for some of you that haven't been here for a while, just a reminder,